Hi everyone, welcome to PolyCloud YouTube channel, your one-stop channel for mastering Microsoft Azure. In the previous model, we have learned about managing Azure identity and governance, and these are all the videos which are already uploaded on the channel. The first three videos are of single part, and after that there are six modules, so they are divided into these videos. If you haven't checked that out yet, make sure you watch those videos. They are very helpful for basic understanding of Azure identities and governance. Now in this module, we are stepping into one of the most essential Azure topic, that is implementing and managing storage. In this part, we will deep dive into Azure storage account and blob. I will just open so let me show you once. These are all the topics which has been already covered in the earlier videos, and in this module, that is implement and manage storage, I've added three videos. So the first one is managing storage account and blobs, learning how to create, configure, secure, and optimize storage account for your cloud workload. So here are what we will cover in this session, that is understanding different Azure storage account, its type, creating them, configuring them, and uploading blobs to them using Azure Portal, PowerShell, and CLI. We will have overview on Storage Explorer, soft delete, and access tier as well. We will implement blob versioning, lifecycle management, and data archival for cost efficiency. So get ready to explore the backbone of Azure data management, that is storage. Don't forget to like, subscribe, and turn on the bell icon to continue your AZ-104 learning journey with PolyCloud. So let's get started.
As an Azure administrator, you will need the skills that will allow you to create and manage storage accounts and blobs. In this course, I'll begin by going over how to plan the number, location, and configuration of Azure storage accounts. Next, I will create storage accounts and manage blobs. And I'll do this using the portal, the CLI, the AZ copy tool, the Storage Explorer GUI tool, as well as PowerShell. Next, I will enable storage account blob features such as soft delete and versioning. Finally, I will configure immutable blob policies and manage storage tier and archiving and automate blob lifecycle management. This course can be used to prepare for exam AZ-104, Microsoft Azure Administrator. Azure storage accounts are used as enterprise cloud storage solutions. They allow us to store a variety of different types of things in the cloud in a secured environment, and we can manage it using cloud utilities like the portal or the CLI or PowerShell. As you can imagine, you need a subscription to work with storage accounts because when you deploy a storage account, you are deploying an Azure resource. So as a result, it means you're deploying that resource into a region. So you have to think about how many storage accounts you might need, perhaps for different uses, different regions, different administrative teams that would have access to it. It's all part of storage account planning. There are four primary types of things that you'll find can be stored in a storage account. The first is a blob, a binary large object, essentially a file. You can also configure file shares. A file share is a shared folder in the cloud, and you can do that within a storage account. The shared folder can be connected to from Linux, Mac OS, and Windows hosts in a variety of ways. You can also have storage queues stored in a storage account. That's useful for messages sent between software components and is usually of interest to software developers. You also have basic table storage, key and value pair storage within a storage account. When you create a new storage account, you will have two access keys. The access key provides full access to everything in the storage account. So, for instance, you could provide a developer with an access key for a storage account if they need full read-write access, as opposed to creating an account for them in your Azure Entra ID tenant and giving them RBAC role permissions to the storage account. The reason you get two access keys is you can have one that's active while you change or renew or refresh or rotate, whatever term you'd like to use. The other key, you should change keys or refresh them periodically. And that's why you've got two, because as soon as you rotate or refresh a key, the old one previous to it becomes invalid. You can also work with shared access signatures. A shared access signature, or a SAS, SAS, allows you to provide time-limited access to a subset of objects within a storage account, perhaps only blobs, let's say. You can even limit it from certain IP addresses. You can also configure storage account encryption, even using your own customer-managed key, which might be required for compliance with certain types of data privacy laws or regulations. You can configure geo-replication for a storage account so that you've got a secondary copy of the storage account and everything in it in an alternate region. So if there's a problem reaching the storage account in the primary region, you've got an up-to-date copy because they're kept in sync elsewhere. We mentioned that storage account blobs are files that you can upload and store in a storage account. Of course, you can also download them to on-premises machines too. So this is basically file storage. You can organize blobs in blob containers, which are analogous to folders or directories on a disk storage device. And there are plenty of blob settings, such as the archiving tier, the hot tier for frequent access to files, the cool tier for infrequent access. You can also automate the lifecycle management of blobs. So for example, perhaps after a certain amount of time has gone by and the blob has not been modified, you want it deleted, or perhaps, if not deleted, archived. You can automate that. You can even enable public access for blobs. For example, if you're using blobs in a storage account to store graphic logos and files for a publicly accessible website, you might enable public access to those blobs so that they would show up on the website without people having to sign in. You can enable versioning for blobs to store multiple versions of a blob. You can revert to previous versions if it was mistakenly overwritten. Versioning is automated where you can manually take a snapshot to accomplish the same type of thing. You can enable soft delete so that even if you delete a blob, it's still available for a period of time before it gets permanently purged from the storage account. Now, we mentioned that blobs are files. There are three primary types, and you can specify this when you upload blobs. You have block blobs, which are essentially smaller type of files like office productivity files, spreadsheets, presentations, documents. You have page blobs, which are designed for more random read and write access on a larger scale, and it lends itself very nicely to virtual disks that might be used by virtual machines. And then you have append blobs, which are normally used when you're writing to the end of a file, such as the case with log files. We've mentioned you can have file shares within a storage account. So when it comes to allowing Windows access, it means connecting over TCP port 445, let's say from an on-premises computer, although it could be a cloud-based virtual machine, to map a drive letter, if it's Windows, to that shared folder. So if you're using Windows for this type of thing, you want to make sure it's up to date and that it's using server message block or the SMB protocol version 3.0 or better. Now, if you don't want to use drive mappings, you could also use a mount point. That's available in Windows, and also if you're doing it through Linux as well. We've mentioned that storage account queues would be of interest to software developers. So in our diagram, we have app component 1 running on the left and app component 2 running on the right. App component 1 can drop a message in the queue in the storage account, and at some point, app component 2 would read that message in the queue and process it. So it's a centralized storage location for inter-application component messaging. We've mentioned briefly storage account tables within a storage account. These are NoSQL-based key and value pairs. It uses an unstructured schema, unlike a relational database, which strictly defines field types, data types, the amount of data that can be put into it, and so on. So this is just key and value pair basic storage. In this demonstration, I'll be using the portal to create an Azure storage account. So we've discussed storage accounts. They're essentially enterprise-based storage in the cloud, where you can store a multitude of different types of items. And we'll review those and take a look at those briefly once we've created a storage account. The first thing I'll do here in the portal, though, is I'll open up the navigator on the left, go down and select the storage accounts view. So any of our storage accounts that already exist will be shown here, along with the resource group it's deployed into and the region or location. So how do you know then, as an enterprise, if you should have one storage account? Because it'll accommodate an enormous amount of data. Or how do you know if you need multiple storage accounts? Well, you might deploy storage accounts in different regions for network accessibility issues. It makes sense if you're in the East US accessing a storage account often that the storage account be in that region. Or you might have a storage account used by a different team, maybe for a specific project or for testing versus production. And you can set permissions for admins as well as people accessing storage accounts differently per storage. What we're going to be doing here is creating a new one. So I'm going to click the Create button up at the top here. As always, we specify the subscription and the resource group for this new object. And we have to specify, of course, a unique storage account name. For the region, this one I'll place in the Canada East region, assuming that most of the access to the storage account will happen in that location. You can't always predetermine that, but that's what I'll do here. I'll leave it on the standard performance setting as opposed to premium, which is going to cost more but gives you better performance. So it says here, premium, recommended for scenarios that require low latency. But in my case, I'm just going to be uploading some office productivity type of files, so standard is fine. Notice that the default setting for redundancy for the storage account is something called Geo-Redundant Storage, or GRS. This means that it will automatically create a synchronized copy of the storage account in a secondary region, a different one. Now, we're putting this in Canada East, so it will pair it with another region, and we'll take a look at that. If you don't want geo-redundancy, so that increases the availability of your storage account in case one region for some reason is inaccessible, you can also configure locally redundant storage, or LRS. And it says here that this gives you protection within a data center against the failure, equipment, or power in a server rack or drive failures. But it's not going to help you if, for some reason, resources in a given region can't be reached. And you can change this after. I'm going to leave it on geo-redundant storage. There's also a check mark to automatically make read access to the secondary copy automatically available. In the event that the primary region, here Canada East, is on, there are a number of options here. For instance, the minimum TLS version for network security is set to 1.2. You don't want to go anywhere below that version as there are known vulnerabilities. Further down, the default Blob access tier is set to hot. This is designed for items in the storage account that are accessed frequently. You also have the cool access tier for infrequently accessed data or backups. And of course, there is a price difference between the hot and the cool tier. You can change that after. This is just the default at the storage account global level. You can actually set the storage tier for individual blobs. Okay, I'll click Next, Networking. The default selection here is to enable public access to this storage account from all networks. That would include other VNets in addition to from the internet, as we are doing right now as an administrator. We could enable public access from selected virtual networks and IP addresses, and of course, when we make that choice down below, we would specify those items. Or you can disable public access and only allow private access. What that means is you're configuring something called a private endpoint, which makes the storage account available to services in a given VNet. But in this case, I'm just going to leave it on Enable Public Access from all networks. I'll click Next for data protection. There are a number of options here too. Do we want to enable soft delete for blobs? So when you delete a blob or a file in the storage account, it's not permanently removed until after, in this case, 7 days. That's the default setting. There are other options like turning on versioning for blobs if you want to retain multiple versions when blobs are modified. And again, you can change some of these things later. Encryption, it's automatically encrypted. The storage account is in its entirety using Microsoft managed keys. If you choose to, you can configure to use your own customer managed keys for encrypting the storage account. Click Next Tags. I'm not going to add tagging. Next Review. And finally, after the validation has passed, we can create the storage account just by clicking the Create button in the bottom left. Okay, the deployment is complete. If I click Go to Resource, it'll take me into the properties of our newly created storage account. And if I scroll down, we can create blob containers or folders, so to speak, like you would have on a storage device, in which we store blobs or files. We can create shared folders in here that can be mapped to in terms of a drive letter from Windows or maybe mounted as a mount point from Linux. Software developers can work with message queues, where software components can drop messages that will be read and processed by other software components. And we have basic key and value table storage. Those are the 4 types of items you can store within a single storage account. Working over on the left, there's our public access option that we set during the creation of every storage account has 2 access key too, as well as 2 connection strings. You can choose to show them. The reason that there are 2 of them is that you can rotate one key while the other remains as it was to allow continued access for anybody that has that other key. Now, a storage account access key provides full read-write access to everything in the storage account. If you don't like that and you want to limit that scope, you might look into then a shared access signature where you can say, perhaps I only want to allow access to blobs and maybe only read access to blobs. Not only that, you can set a start and an expiration date and time of when that would be in effect, and even from certain IPs. If I click on redundancy in the left-hand navigator, do you remember that when we created this storage account, we defined that it would be in the Canada East region, but we also had geo-redundancy enabled. Is it picked the next nearest paired region, which in this case is Canada Central. And of course, geographically, it's showing us down on the map. So if for some reason the Canada East region for Azure services is inaccessible, we still have access to the stuff in the storage account in the Canada Central region. And it's kept in sync all by itself. So this gives us a general idea then of what to think about when planning for storage accounts, and of course, how to go ahead and create it using the portal. One important aspect of managing Azure storage accounts is getting files into the storage account. In other words, uploading blobs. So we're going to take a look at how to do that. So I'm signed into the portal already. Over in the left-hand navigator, I'm going to go down and select storage accounts. The storage account I'm interested in working with for this example is called Store Account YHZ-44. I'm going to click to open up its properties. The navigator on the left, I'll scroll down under Data Storage, and I'll choose Containers. This is where we can create blob containers to organize blobs. For example, over on the right at the top, if I click the Add Container button, I can specify a name. So in this case, I'm going to call my blob container projects. But notice what I've done here. It's all lowercase letters. If I were to perhaps change the P to a capital P, doesn't like it. It says it can only contain lowercase letters. No problem. And the default configuration is that there is no anonymous access allowed to this blob container, which would mean connecting via a URL, for example, without signing in. I'll click Create to create this container. So there's the project's blob container. Notice if I click on that blob container, now that I'm within it, of course it's empty, we have the option of uploading. We could change the access level. In this case, it's grayed out because at the storage account level, anonymous access is disabled. So of course within it, it will also be disabled for things like blob. If I go back into the properties of the storage account and scroll down in the left-hand navigator all the way down under settings, and if I were to click configuration, notice on the right, the Allow Blob Anonymous Access option is disabled. And so that's why it's grayed out when we go to work with our blob container. We could change it, but I'm not going to do that. Okay, let's go back into projects, and I'm going to click the Upload button. I'm going to upload some files from on-premises, my computer, into the cloud. So we could browse for files or drag and drop them into this area in this window. Okay, so I've selected 3 sample project files. I can choose to overwrite the files if they already exist in the storage account. They don't. Advanced, we can specify what type of blob it is. A block blob is most appropriate for office productivity type of files, but a page blob lends itself to larger files where there might be read and write randomly throughout the file, such as the case is with virtual hard disks used by virtual machines. You could also have an append blob, such as for log files, where you keep adding to the end of it. So I'll leave it on block blob. It's picked up the hot access tier, which is used for frequently accessed files. It provides less latency than using cool or cold for infrequently accessed files. But notice it says hot, and in parentheses it says inferred. That means it inherited this setting from the storage account. Of course, if I want to change that, I can here. We can also specify tag, key, and value pairs for the uploaded blobs. It'll be applied to all of the blobs that we are uploading in this session. I won't be changing any of that, so I'm going to go ahead and click the upload button. Now, because they're small files, they'll be uploaded immediately, and they show up here in the project's blob container. So they're showing up with the modification date and timestamp. The access tier is cool, and the blob type in this case is block blobs. If I click on any one of those blobs, it takes me into some properties of that blob. So we have the size shown here, whether it's encrypted server-side, that's set to a value of true. That's the default for a storage account using Microsoft managed keys. Top, if we've got versioning enabled to track multiple versions when a file is modified and saved, they would be shown here. That happens automatically when new changes are saved, or what's similar in a way, conceptually, is to take a snapshot, which is a manual process by clicking the Create Snapshot button. You can also choose to edit the file. Now, because it's a text file, we have an inline editor directly in the web browser. Otherwise, you would be prompted to download the file and then use some local app to edit it. We can also generate a shared access signature, or a SAS, for this individual file, this blob, which can provide time-limited access to the course. If I were to select the blob back here in the blob container, we have a number of options across the top, like delete, change tier. So currently it's in the cool access tier. We selected that upon upload, but we can change it here. If we go back in our breadcrumb trail, in our links in the upper left, back to our blob containers, there's the project's container. Notice that if I click the three dots, the context menu to the far right of it, we have a number of options. So you might have another service or a user that needs access directly into this container. So you can provide that access by giving them the URL. Other options would include generating a shared access signature to provide access to the blob container, modifying the access policy. One of the things that you might do here is configure an immutable blob storage policy, such as for legal hold, to prevent items from being modified for a period, regardless of what admin permissions one might have. And of course, we could choose to delete the blob container. When we do that, it states that this will essentially delete the container and its contents, but to a soft deleted state. So it is available for recovery. You can undelete it for up to 7 days. So that gives us a general sense of how to work with blob containers and how to upload blobs into the storage account using the portal. In this demonstration, I'm going to be using PowerShell to upload blobs into an Azure storage account. Now, to do this, we can work with PowerShell commandlets on premises, and therefore those commandlets would then be able to talk to local file systems on your on-premises computer, and that would be the source of what you're uploading into Azure. Also, we could do it through Cloud Shell, which is what I'll be doing. But of course, when you're in Cloud Shell, you don't have local access to the local file system on the computer you're running Cloud Shell from. But you can upload files into Cloud. You might recall that Cloud Shell actually uses a storage account. If I go to my storage accounts list here in the portal, there is a storage account that got created the first time I launched Cloud Shell. It prompted me to create it, and it put it in a resource group whose name begins with Cloud Shell Storage. So that allows for persistent storage when you're working in Cloud Shell, even between the top. Now it's placed me in a bash environment, so I'm going to click on that in the upper left and switch over to PowerShell, and I'll click Confirm. If I were to type dir, it would show me any files in the file system here. This is the storage account we were looking at previously in the portal. One of the buttons up here is an Upload Download Files button. So I'm going to click that to get some files in here for this example, because I happen to be using Cloud Shell. Okay, so I've uploaded a sample customer data file. Status in the bottom right shows that as being complete. So if I just clear the screen and do a dir again, we now have our customer_data.docx file. Next thing we have to determine are which commandlets we should probably use. I'm going to run git-command * storage account, assuming that's part of the name. It looks right, although there are quite a few commandlets here. but it's pretty easy to pick out which ones might be of interest to us, like a new-AZ storage account if we wanted to create a storage account from PowerShell, but we don't want to do that. But I also have get-AZ storage account to retrieve information about a storage account that already exists. That sounds like something that will be of interest. There are a few other commandlets we'll be using, of course. Let's get started with it. First thing I want to do is just run get-AZ storage account, and it returns back the list of storage accounts that we saw previously in the portal interface. We're going to be working with one called store account YHZ-104. One way to work with storage accounts in PowerShell is essentially to store a reference to a storage account in a variable. And then whenever that reference to the storage account is needed, you just pass off the variable. So that's what I'm doing here. I'm creating a variable called $CTX, which stands for context. It could be called anything. And I'm running get-AZ storage account after the equal sign, -R for resource group of HQ-name, and then I'm specifying the name of the storage account I'm interested in. The next thing I want to do is store a reference to my storage account in a variable. It just makes it easier in PowerShell if I'll be using a number of statements that require a reference to the storage account. I just want to pass off the variable name instead of the details all the time, like the resource group and the name of it. So I'm creating a variable here called $CTX, that stands for context, equals get-AZ storage account -R for resource group, HQ-name, and the name of the storage account, of course, is store account YHZ-104. So if I type in $CTX just to see that it looks like we have a variable that is indeed a storage account type of variable with a few details for that, that's perfect. But what I really need to do here is reference $CTX dot. Well, actually, let's talk about how you would find out what the properties are. I can pipe a variable or a statement in PowerShell, so the vertical bar pipe symbol. I can pipe that to get-member, let's say -type, property. Now the properties for this thing to the left of the pipe. And these are the properties of the storage account, of course. One of the things that we need to have is a property called context. That's what we really need to use our variable effectively. So I'm going to type in $CTX, that's my context variable, equals $CTX, so itself, but we'll add more to it, dot context. So now if we type $CTX to see what's in our variable, now we've got the endpoints, a way to actually make a connection to that referenced storage account to do. All right, now we can move on. So now what I'd like to do is create a blob container. For that, we use the new -AZ storage container commandlet. So -name, I want to call it customers, -context. All I have to do to reference everything about that storage account is simply use $CTX, my variable, as the value of the -context. Too easy. Enter. Okay, so it looks like our customers blob container was created. Of course, we can check our work here in the portal. If I go into my storage account, and down under data storage, if I click containers, of course, if I open it up, it's empty. At least it's empty for now. Back into Cloud Shell. If we do a dir, let's remember our file name here, customer_data.docx. Okay. The way that we upload blobs into a storage account in PowerShell, or at least one way to do it, is to use the set-az storage blob content commandlet. We then use the -file parameter and we reference the file that we have available locally that we want to upload. I'm just going to make sure I have valid quotation marks here. I'm then going to use the -container parameter and specify that I want this uploaded into a blob container that's already there called customers. We just created that a minute ago. And then, of course, -blob, what do we want it to be called in the storage account? I'm just going to use the exact same original file name. And finally, how does it know what the storage account is? Well, -context, and we pass it our $CTX, enter. Notice, however, it says it could not find the file, customer_data.docx, even though if we do a dir, it's there. It's a case sensitivity issue, in this case referencing the file name. The C in customer should be capitalized, and the D in data should be capitalized. So we'll use our up arrow key to go back up to that command and we'll make the appropriate changes. This time it loved it. Looks like it went through. Of course, we can check our work back here in the portal by clicking refresh as we were already in our blob container. There's the customer data file. Back in PowerShell, we could also get the same information using get-az storage container, -name is customers, -context, $CTX, and then we're going to pipe that to get-az storage blob. So get the blobs in the container, and then we're going to pipe that, so we have a second pipe here, to the select statement because all we want to see are the names of the blobs. So we're asking only to select the name property. And the resultant output, of course, is showing us the blob that we uploaded. Okay, in this demo, I will be using the Azure CLI to get blobs into an Azure storage account. I'll be using the CLI here through Cloud Shell, where I'm already signed into the portal. Click the Cloud Shell icon to launch it. And the first thing I'll do here at the command line is I'll run AZ storage account list. Now, of course, when I do that, it'll list storage accounts all right, but also all of their properties. We're really just looking for the names here. So I'll bring that command up through my command history, the up arrow key on the keyboard, and I'll add --query space, open, close, square bracket. And we want the .name property. There we are. That's easier. We're going to be working with the storage account called store account AZ-104. I'm going to be using one of the storage account access keys as an authentication mechanism when I am uploading blobs. Remember that every storage account has two keys. It doesn't matter which one you use. So I can get that list of keys for a storage account here in the CLI with AZ storage account keys list --account -name. Well, the storage account is called store account YHZ44 --resource -group. It's in the HQ resource group --output. I want it formatted in a table format. Okay, so we've got key 1 and its value is shown here. It wraps onto the next line because it's pretty long. And the same goes for key 2. Which one should we use? Doesn't make a difference. So I'm going to select key 1 and I'll press Control-C to copy that to my Windows clipboard. Next, I want to store the name of my storage account in a variable. We don't have to do that. That's simply what I'm choosing to do here. Now we're in a bash shell, we're not in PowerShell, so I can work with variables and set their values without having a preceding $sign. The $sign that is here is part of my command prompt. It's not part of what I'm typing in. So my variable is Azure_storage_account equals, and in double quotes, I've got the name of the storage account, store account YHZ44. So if I echo back the variable name, and when I want to refer to the variable's value, that's when I need to prefix the name of the variable with a $sign. So I can just echo back $, Azure_storage_account. It's the text string we have stored in there. I want to do the same type of thing, except I want it for the storage account access key that I copied previously. So I'm going to make a variable called Azure_storage_access_key, and it's going to equal the storage account access key that I had copied. That'll be in double quotes. And just as we did with our previous variable for the storage account name, we can echo back this variable name prefixed with the $sign to make sure it contains what we think it contains, in this case, the storage account access key. In our next statement, we are creating a blob container in the storage account. We do this with AZ storage container create --name. I want to create a blob container called Western Region --account -name. Well, here I'll just reference our Azure storage account variable. And of course, prefixed with the $sign. The next parameter is --account -key. Again, I'll specify our variable, except this variable is for the storage access key, and again, prefixed with the $sign, enter. All right, it returns created true. We can always go back into the portal if we really wanted to and open up that storage account and go down under containers on the left in the navigator and sure, there's Western Region. Of course, nothing yet. Let's go back to the CLI. I'm going to click the Upload, Download Files button at the top here in Cloud Shell because I want to upload a sample budget file from my local computer into Cloud Shell storage. If you're working with the CLI locally, you won't have to worry about that. So if I type dir, we've got budget1.txt shown here. Perfect. That's what I want to get into that Western region blob container. To upload a blob, I'll use AZ storage blob upload -- container - name. It's Western region -- name. This is the name that the blob will assume once it's uploaded in the storage account. So budget1.txt. Then -file is a parameter that allows us to reference the local file that we want to upload. Here it's // for current directory, budget1.txt with a capital B for budget. The next parameter, -- account - name. As we did before, we'll use the appropriate variable for that. And the same is true for -- account - key. Enter. Okay, this is good. It's returning some details like the last modification date and timestamp, and so on. We can verify our work in the portal by refreshing our blob container view. There's budget1.txt. But we don't have to keep using the portal to verify our work. We can see the blobs in that blob container with AZ storage blob list -- account - key, our variable, -- account - name, our variable for that, -- container - name is Western region. And then I'm just going to add to the end of that -- query space open close square bracket .pay. And it's returning just the name property for any blobs in the Western region blob container.